Welcome back, students. We'll be looking at section 2.6, terminology for ratios, proportions, and percent. Our first blank is going to have the term ratio. Ratios can be written in three ways. It can be written with the word to in between the ratios, so A to B. You can have a colon between, so A to B. Or it can be written as a fraction, A to B. All three of these mean the same thing. And it's very important that when forming ratios, if it involves money, the money is always placed in the numerator as the top number of your fraction. So let's look at a few examples. Ratios are basically comparing one thing to another. So let's say you're talking about the number of girls versus the number of boys in a classroom. You would say like 5 girls to 7 boys. So every time you count 5 girls, that means you're going to also count 7 boys. If you counted 10 girls, you would have 14 boys, and so on. So the ratio is how many girls to how many boys in that example. So let's look at the first one, 3 feet to 42 inches. So 3 feet of one thing in, let's say, real world measurements is equivalent to 42 inches in some kind of diagram or model, for example, a map. So let's say you have a paper map and you have city A and you have city B, okay? And I'm not gonna use the 3 feet to 42 inches because I can't draw that out on here. So I'm gonna give you some different numbers. Let's say for every inch, so every 1 inch on the map, that is equivalent to 10 miles in real life, okay? So we've got 1 inch there and we have 1 inch here. So again, every 1 inch to 10 miles. Okay, so the first number is our model, our map, our paper map. The second number is real life, the real distance. So I can look at this paper map and tell that the real distance between city A and city B is actually 20 miles. That's how ratios help us in real life. Because we can't draw a map with actual 10 miles on it, right? We need to give it a smaller version, an equivalent smaller version that we can then convert to know the actual distance. So let's look at this first one and let's practice writing these out. So they gave us the version with the word to in between. So we're gonna write it in the other two versions. We have 3 feet, colon, 42 inches. The second way would be 3 feet over 42 inches. And we would read these the same way, 3 feet to 42 inches. Our next one is 5 hours, colon, 2 days. Or we could have 5 hours to 2 days in fraction form. We will be using this form the most. All right, so now we have one with money. And remember, our important tip said, if you have money, it's always going to be in the numerator, which means it's always going to be your first number listed. So $15 to $15.36, colon, 24 ounce. Write it in fraction form. So what this means is for every 24 ounces of something that you get, you're going to spend $15.36. Now, a way that we can use ratios is the term proportion. These are 2 or more ratios that are equal to each other. So for example, we have 2/3 equals 18/27. I'm going to show you how that is true. And you can probably at this point recognize this as yourself. If I factor both of these numbers with 9, 18 divided by 9 gives me 2, and 27 divided by 9 gives me 3. So they are, in fact, equivalent to each other. The 18/27 is just a larger version of the same amount. All right, so let's look at cross products of a proportion. It's the process of cross multiplying to simplify or solve proportions. Sometimes we know 3 parts, but we're missing that 4th part of the proportions that are being compared. So we have to be able to find that 4th part, and that's where cross multiplying comes in. So I'm going to draw my little arrows to indicate what I will be multiplying against what. I will be multiplying A times D, and I get AD. Then I put my equal sign, because now I'm going to form the other side. B times C. So I get BC. This is our pattern that we use for cross multiplying. Now let's look at the next example. We have A to 24 equals 15 to 16. Where A is at, that's the value that we're missing. That's the value we're trying to find. So again, I'm going to draw my arrows. I get A times 16. So that's 16A. I have my equal sign. I'm going to form the other side of it now. 24 times 15 gives me 360. Now I'm going to actually solve for A like we've been doing in our past sections. You know this part. I'm going to divide both sides by 16. And I get A equals 22.5. So our first ratio in this problem, the A to 24, is actually 22.5 to 24 is equivalent to 15 over 16. Now let's look at our next problem. P plus 3 over 3 equals P minus 5 over 4. Looks slightly different, right? We've got more going on in these numerators than we did in the previous problems. But that's okay. We're still going to cross multiply. So I'm going to draw my arrows. So I'm going to draw my arrows. And I'm going to set it up in a particular way. So I have 4. I'm going to do parentheses P plus 3 because that 4 needs to multiply against both of those items, not just one of them. Equals, now I've got 3 times the other side. So I have 3 parentheses P minus 5. Now we get to distribute to actually solve the problem. So I get 4P. 4 times 3 is 12, so I get plus 12. 3 times P is 3P, and then 3 times negative 5 is going to give us minus 15. I can subtract 12 from both sides and end up with 4P plus 0 equals 3P minus 27. Rewrite it so we can see what our next step is. Now I need to move my 3P to the same side as the 4P. So I'm going to subtract 3P. I get 1P equals 0 minus 27. So my answer is P equals negative 27. Let's scroll up. Now we're going to look at some word problems where we use proportions to actually find missing values. So we've got an important tip here. Make sure you match type placement. What I mean by that is in this correct version here, you'll notice in the first ratio, I have inch to feet. I have the inch in the top, I have feet in the bottom. On the other side of the equal sign, I also have inch in the top, feet in the bottom. That is what I mean by making sure you match type placement. The incorrect side shows you what not to do. I have inch in the top, feet in the bottom. When I go to the other side of the equal sign, I have feet in the top, inch in the bottom. That does not match. Make sure if you have one measurement in the top, you have the matching type of measurement in the top on the other side. Don't flip them. Make sure they're balanced with each other. All right, so let's look at our first example problem. We have 12 gallons of diesel fuel that costs $40.80. That's my first ratio. And remember, we put money in the top. So I'm going to have $40.80 to 12 gallons. Okay, so that has formed our pattern that our other side needs to follow. So our key is going to be money on top, gallon in the bottom. So that means we need to have money in the top, gallon in the bottom on the other side as well. This is our key that we're going to use. Let's find the other ratio. To the nearest cent, how much would 16.5 gallons of the same fuel cost? All right, so we're missing the money amount of the other ratio. So let's set up our problem. We have $40.80. And we have 12 gallons in the denominator. And remember, we have to follow that pattern. So on the other side, I don't know the money amount. So I'm going to use M for money. And then we have our gallons in the bottom. That's the pattern. So I'm going to have 16.5 gallons down here. Now we can use cross multiplication to find the answer. So 12 times M is 12M, my equal sign. $40.80 times 16.5 gives me $673.20. Now we can actually solve for M. So I'm going to rewrite it so you can see that step separate from what we just wrote down. Oh, it would help if I wrote the number correctly, wouldn't it? All right, we're going to divide both sides by 12. And we get M equals $56.10. So when someone buys 16.5 gallons, it's going to cost them $56.10. Next example. A wall map of the United States has a distance of 8 inches between New Orleans and Chicago. All right, so we're going to have New Orleans. I'm going to put an O for New Orleans, or N-O. That's what I'll put, N-O. And then for Chicago, I have C. On the map, on the wall map, this distance is 8 inches. Okay. They're actually 912 miles apart. So actual, real life, is 912. The actual distance between Milwaukee and Seattle is 1,940. So we've got Milwaukee, and we've got Seattle. And the actual is 1,940 miles. How far apart on this map are Milwaukee and Seattle? Okay, so that's what we're looking for. We're looking for this value here, the map distance on the paper distance. So let's set up our first ratio so we can figure out the pattern that we're going to follow. We need our key, basically. So let's make our key. I'm going to do inch to miles. So that means the other side will also be inch to mile. I need to follow that pattern when I set up this problem. So my first ratio, I had 8 inch to 912 miles. My second ratio, I don't know the inch, so let's use D for distance. We do know the mileage. It's 1,940 miles in actual life. Now we're going to do cross multiply on both of these. On the first one, I get 912D. The second side, I have 8 times 1,940. That's going to be quite a large number. We get 15,520. Rewrite this just so we can show the next step. I'm going to divide both sides by 912 to get D by itself. And we end up with D equaling roughly 17.02 inches. So whenever someone measures 17.02 inches roughly on that paper map, then that is equivalent to an actual 1,940 miles in real life. This is actually how people would find the distance between places before we had Google Maps and other map technologies that would do all that work for us. All right, percents. A percent is a ratio where the second number is always 100. 50% represents the ratio of 50 to 100. That is 50 over 100 or 0.50, which that makes sense because we learned how to turn a percent into a decimal, right? We would have moved it 2 times and got 0.50, which is this. And then to turn it into a fraction, we would have taken that 50 and put it over 100 because of the furthest right place value is the hundredths with that 0 at the end. So we've already actually done this, but now we're just learning what this is called as far as a ratio goes. Let's get rid of that. All right. So let's look at the 4 different versions of a same formula, basically, to find a particular answer in a certain type of problem. Depending on what we're looking for, we're going to use one of these different versions to find that answer. So one version is part to whole equals a missing part to a whole, which is the 100. That X is the percent, okay? So we're basically looking for a part to whole that is equivalent to a part to whole. Another version might be amount to base amount, and then again, part to whole. Another version we might use is the original number times percent gives us a new number. You'll use that a lot when you're trying to find a sale amount or what was the percentage off of a certain item. You'll use that particular formula. All right, this next one is pretty much the same version of that, but with some different terminology just to kind of help you when you see these word problems. So you'll have original cost, again, original number, original cost times percent gives you the discount amount or the increase amount, depending on what the problem is. All right, so let's look at some not practice problems, but some problems to show you how these work. 90 is what percent of 360? All right, so I've got the word percent. I also have the word of. Remember, of means multiplication, okay? So I'm going to use this first one of these types here for this particular problem. It's got multiplication in there. 90 is, okay, the word is equals. Remember, we talked about that before. So 90 is what percent? We don't know what percent of 360. 360 is the original number. So I'm going to have 360 times the percent that we don't know. And I need to give it a variable. I'm going to use x. So 90 is what percent of 360? Remember I said the word of is multiplication. All right, so now we can actually find x. I'm going to flip the problem though, just so our x is on this side. Divide both sides by 360. And we end up with x equals 0.25. Are we done? Well, I need to look back at the problem. What did it ask us? What percent? So we're not done. I need to turn this decimal into a percent. So remember, to do that, we move our decimal to the right 2 times. So our actual answer is 25%. So 25% of 360 is 90. All right, so 90 is what percent of 360? It's the same problem, but I'm going to use the part to whole, the amount to base version to show you can actually use that to solve this problem and get the same answer. So whichever one makes the most sense to you, you can use either one. They give you the same outcome. So 90 is what percent of 360? All right, so 90 is the part, 360 is the original whole, the total amount that something cost. So I'm going to have 90 as my part, 360 as my whole. On the other side, the x represents the percent. We don't know the percent. So I'm going to have x. And remember, the second number of percent as a ratio is always 100. So that's why we have 100 in our formula. Now I'm going to cross multiply. And I end up with 360x equals 9,000. Okay. Bring that up over here just so we can see it. So 360x equals 9,000. Divide both sides by 360 to get that x by itself. And I end up with x equals 25. All right, now, one thing to point out, in the first problem, we ended up with a decimal, right? We had to move that decimal to the side 2 places. But remember that the decimal is the same as this right here, this fraction. So we have 25 over 100 is what we essentially have if we plugged it back in right here, okay? So let's think about that. That's our version that is the same as a percent, right? So if you use this pattern, we just need to write that our answer is, in fact, 25%. We don't have to worry about moving the decimal. So that's the difference between the two. If you use the first example that I gave you, make sure you turn that decimal into a percent. If you use the second version that I showed you, you're actually ending up with your percent number and you don't have to worry about moving the decimal. You just have to give it the percent sign, basically. That's the only difference. All right. Let's look at solving an applied percent problem. So let's look at a word problem where we're actually going to be using these types of formulas. A winter coat is on a clearance sale for $48. The regular price is $120. What percent of the regular price is the savings? All right, so the sale price is $48. That's what you're going to pay now. The original, the regular price, was $120. So pretty good sale, right? What percent of the regular price is the savings? We don't know the percent. So I'm going to put a question mark. Before we can actually use our formula, we need to figure out what the savings was. We don't know how much was discounted, basically. So we're going to use the original formula times percent gives us the discount, right? But we need to know the discount to plug in because we're actually looking for the percent. So I need to take 120. Let's see, I'm going to come over here. 120 minus 48 gives us $72 in savings. Okay, that was the discount. That was the amount that was taken off. Now we can use this to find percent. So the original the original number was 120 times the percent we don't know. I'm going to give it X equals the discount, 72. Now I can actually solve my problem. So 120X equals 72. Divide by 120. Divide by 120. I end up with X equals 0.6. Now remember, I told you, if you end up with a decimal like this using this particular form, we need to turn it into a percent. So I'm going to move it 2 times. I need to add a 0 there. I'll do that in a different color. And we end up with our percent is a 60% discount. Okay, let's do another one like that so I can show you again just the steps. A newspaper ad offered a set of tires at a sale price of $258. So our sale was $258. The regular price was $300. So regular, $300. What percent of the regular price was the savings? All right, so we've got original times percent equals discount. Okay, so back up here, remember it said what percent of the regular price is the savings. They wanted to know what the percent was. But before we could do that, we needed to find one of the pieces so that we could actually use our equation, our formula. We need to do the same thing here. So it says the regular price was $300. What percent of the regular price was the savings? We need to know what the discount was first before we can find that. So again, I need to take the regular, subtract the sale cost to find how much was actually discounted. So 300 minus 258 is $42. That's the savings. That's the discount, okay? Now we can actually use our formula. So the original number was 300. We don't know our percent, so I'm going to use X. The discount was $42. Rewrite it so we can see the next step. I'm going to divide both sides by 300. And I end up with X equals 0.14. I need to turn that into a percent. So I end up with a 14% discount. So now we know the percent that gave us that $42 in savings. All right, guys, that's the end of our terminology video. Let's look at our memory verse. Each of you must bring a gift in proportion to the way the Lord your God has blessed you. Deuteronomy 16:17. Look at that. We have the word proportion in the Bible. All right, guys, I hope you're having a great day. See you in the next video. Bye.